get started. All right, Science with Miss Miranda again. Today who can start us off? All right, let's start with Cherry. Go ahead and do number 1, starting with today.
Today we will go over the floating or sinking homework.
Very good. Number 2, Sino. Go ahead, number 2.
Today we will watch more homework videos.
Very good. Number 3, how about Sophia, number 3?
Today we will beginning learn.
Okay, today we will do some activities with volume and mass. Last one, how about Taylor?
Today we will begin learning how to change matter.
All right, good job, everybody. Let's get going then. You guys are doing amazing so far. So we're gonna share homework videos. 3 more homework videos from Friday. Since you guys put a lot of work into it, I wanna show a few. And we're going to start with, we'll do pasta, moon, and puppy. Those are our 3. Here we go. Let's try this again.
Hello everybody, my name is Poppy. Today I will show you how to make a flying boat. I make a flying boat to play and have fun. The materials I got here is scissors, paper, string, balloon, and tape. The balloon is light, so the paper is light, so the balloon could carry up, and the paper was thin, so we could fold it.
Notice, guys, Puppy is saying the properties of these that's letting them use it. The balloon is thin, so it can fill up. The paper is bendy, right? She's talking about its flexibility. So this is why these materials are good for the job.
The paper is color white, but you could use any color you want. I use a balloon to carry the paper up. The balloon is stretched, so we could blow gas inside. The balloon is green. Now I will make the flying boat. First, we will make a boat. We will make a rectangle. And we fold it into a triangle. And we fold this up. Fold this up. And open.
So fast. Wow.
Then we finish our boat. Now we will take the string and cut out the tape. Then we take the tape, stick to the string, and now stick it to the boat. The next one, we do that with the balloon. Finished now. Now I will show you how to play it. First we upload the balloon. To off gas.
All right. Can someone tell me something that Puppy did a good job of? Anyone have something to say to Puppy? Jack?
Her project is fun.
Yeah, her project looks really fun, right? Let's do pastas next. Pastas is just about weighing things, but I want you guys to pay attention to how he compares the weight of different types of matter, okay?
Hello everyone, my name is Pasta and today I'm going to measure the weight of these objects. As you can see here, I have 5 objects and I know they are solids because they have their own shape. They are different from liquids because liquids don't have their own shape, but they take the shape of their container. Now, let's start.
All right, so started off with some properties of solids and liquids and how they're different.
This is 150 milligrams. Grams. Let's measure the rock. This is 300 grams.
I'm gonna skip forward a little bit. We do a book, and then the bowl. And each time Pastor writes it down in his notebook. Let's look at the next one.
Okay, this is 650 grams.
So this last one was 650
My
grams.
conclusion is that the hammer is the heaviest object of the 5 objects I have measured. I know that because it is 650 grams. Thank you, everyone.
Why do you guys think Pastor wrote down all of his measurements? I know, why did Pastor write down all of his measurements? What do you think? Sophia?
So he can remember the letter, so he can know what is the less and what is the milligram.
Excellent, exactly. He can remember the grams, he can see the weight, and then he can compare them. He could tell us which one's the heaviest, which one's the lightest. Do any of them weigh the same? And our last one, this one is special today because we are learning about something called solubility, which we can see an example of here in Moon's video.
Hi, my name is Moon. Today I will make fruit jelly. The first step we have to buy all the things we need. But if we use for home, you have to check all the things that you need to make jelly. It must be good. I'll stir.
This is a plant. This is butterfly peas.
This agar powder and butterfly pea and watermelon and a mold to make fruit jelly. I forget to add this orange to make jelly, fruit jelly too. Hey, here. I have finished the watermelon and put it in a sheet. Now I have finished 450 milliliters. It's the agar powder with cold water.
So this is the part I want to pay extra close attention to. I want to know what disappears in the water and what can you still see? What does not disappear in the water, okay?
Nice. I use sugar and butterfly pea and put it in. I will mix the butterfly pea, sugar, and stir it in the pan. I will cook and stir until boil. Here. When sugar and flour disappear.
Okay, so she said she's stirring it until the sugar and the flour, I think she means the agar powder, the sugar and the agar powder. The agar is what makes it turn into jelly. She's stirring it until these things disappear. When a solid disappears in a liquid, we call that soluble. It can go in the liquid and disappear. Everybody, go ahead and unmute.
Soluble.
Good. Soluble, when a solid can disappear in a liquid. So the agar and sugar in this case. Jack, please wait your turn. Agar and sugar in this case, she can stir it and mix it until it disappears, until it's in the water and the solid becomes a liquid.
Yummy. Now I will make a colorful plate. Next, I have a beautiful fruit jelly. Do you want to try it?
All right, and then she has a little part at the end. Let's take a look.
I have made it by butterfly pea, oranges, and watermelon. But you don't need to use oranges or watermelon because that is my best favorite. You can use other things too. When I make it finished, I have to put in the freezer so it will be cold, so it will be yummier. When it's freeze, you can just put the jelly, fruit jelly in the freezer for just a couple of minutes. So, when you put more minutes in it, you got this fruit jelly.
All right, nice job, Moon. Excellent work. Okay, guys, who has something to say about Moon's video? What did she do a good job of? What do you think?
I miss Miana, but I see a little bit more of
Who would like to say something nice about Moon's video?
me.
Go ahead, Pasta.
She made the thing by putting in the freezer.
Okay, yes, that's a good observation. The liquid turned into a solid when she put it in the freezer. Very good observation. Anyone else have something to say? Okay, very good job, Moon.
Frozen. It was frozen.
Let's do a quick look at your sink or float homework. Yeah. We got quite a few. I got pictures, I got video, I got writing, I got a lot of things. So let's just go through a couple of them. This one is banana. It looks like some of them are floating. Nice, the paper floats. Very good, banana. And we even have a video. Here is Blue Moon. Blue Moon did writing. The rock dives to the bottom. The paper ball floats at first, then it dives to the bottom. And remember, we want to use the word sinks. The plastic ball floats on the water. Excellent. And there are pictures to go with blue moons. And a video. Wow, amazing, guys. Bunny did a video. Cherry did a video. Let's see Sino. Here, this ball floats. Very good. And this is Zook's. Zook has a cup that kind of floats. The Eiffel Tower that sinks. Ooh, Rubik's Cube floats a bit, doesn't it, Zook? Very nice. But it mostly sinks. Very good. And the writing. Excellent job, Zook. Milk has a video. Misha, pictures. Here are Misha's 3 things. Even though this one is smaller than this one floats and this one sinks. Why do you think that is? Anyone have any ideas? Ray, go ahead, Ray. We haven't heard from you today.
A smaller thing because it has some air in it.
Okay, because, say one more time, Ray.
But it doesn't go air inside it.
Okay, excellent. The smaller one might sink because there's no air inside of it. There's no air inside of it.
I have another idea.
Anyone else have something to add? All right, go ahead, Pasta.
There are tiny bubbles around the M thing.
Okay, maybe the M has some bubbles around it. Here's Moon's, and Moon also has a video of these 3 things in the water. Puppy, very good. Again, this one even has some air in it, but the pencil sharpener sinks and the big ball floats. And we're gonna put a new word to this. If it floats but it's bigger, that's because it's less dense. And if it sinks, it is more dense. This is called density. Is how much it weighs for its size. So even though the pencil sharpener is smaller, it has more matter. And the ball is bigger, but it has less matter. Okay? So everyone say,
Miss Mana.
less dense, more dense. Everyone go ahead and say that.
Less dense, more dense.
Density.
Less dense, more dense.
Miss.
Very good. So we learned density and soluble already. All right, we've got to move on. Okay? And I see Ray, Rosie, Sam, some more videos. Susu has a video. Very good job. You guys will go over your homework a bit more with Miss Hun. All right, let's do some experiments and activities together at home. Did anyone bring a measuring cup or a scale to class?
Me.
Yeah.
Me. Yeah, me.
I see a few people. Blue Moon, Susu, Moon, you have yours. Milk, you got measuring cup to class?
Me, I have a scale.
Guys, we don't have to say me. I can see your hand in the video, okay? Nice, I see Banana has his. Excellent job. Okay, I have my phone here. I just joined the meeting. So I might do it so I can show you the video on my phone because I think it might be hard to show you on my laptop. So I will do an example first, and then I want some of you with the liquids to also do an example, okay? So it's because I wanted to show you guys this a bit easier. So these are the materials that I have with me today. I have 3 different sizes of measuring cups, a scale, or sorry, not a scale, a balance, and some different materials to weigh. So the first thing that I wanted to show you guys, I'm going to put 100 milliliters of water in here. Milliliters. Okay. Now, who can tell me, what shape do you think this is? What shape would you say this is? Taylor, what shape do you think this is?
A rectangle.
A rectangle? But the top of it is a circle.
A cylinder.
Yep, try again, Taylor. Say one more time.
A cylinder.
A cylinder, very good. Now, I'm going to move this 100 milliliters of water into this other measuring cup.
Okay, how do amphibians change?
Okay. Now, did the volume of my liquid change? Rosie, how many milliliters used to be in this cup?
100.
Very good. Now, Cherry, how many milliliters are in this cup now?
100
100, can you say milliliters?
milliliter.
Very good. So, Cherry, did the volume change? Cherry, what do you think?
The volume does change.
It does change. Is there more water now?
Yes.
There is? Let's see if someone else has an idea. Blue Moon, what do you think?
Doesn't change.
It didn't change. Very good. Here we had 100 milliliters. Here we have 100 milliliters. They are the same amount of water. Milk, what did change from here to here? What changed?
A big cup poured into a small cup.
So the volume is the same. Both times the water was 100 milliliters. But what's different? Let's get another help, Bunny. Bunny, what changed from here to here?
The shape of the water changed.
Go, everyone, the shape is changing. And look, I'll do it one more time. Ready? I have 100 milliliters of liquid. That is my volume. Now, I still have 100 milliliters of liquid. The same volume. So what changed? Sam, what would you say changed? What stayed the same and what changed?
The milliliters stay the same, and the shape don't stay the same.
Very good. Okay, so let's see. Banana. Put this on for a second. Banana, You have a measuring cup, right? Do you have any liquid in your measuring cup? No? Could you go put some water in it? Go put some water in it. Let's take a look.
Cup and I have the water.
Who said that, Taylor? Cherry? Cherry, let's see yours while we wait. Cherry, can we take a look at your measuring cup? All right, we see Cherry adding some water into her measuring cup.
Sẽ cho cái nước thấm vào đây xong rồi.
All right, Cherry, what is the volume of your liquid?
Why did this frog think it was? Why did it tackle?
200
200 what?
milliliters.
Very good, 200 milliliters. Cherry, what would happen if you moved that to a different cup? Would you still have 200 milliliters?
Yes.
Yes. Would it still be the same shape?
No.
No. All right, Banana, are you ready? Oh, Banana's taking too long. Let's take another look now at this scale. All right, I've got quite a few different things here. One tape, two tape. All right, this tape is smaller than this one, but it's heavier. What word did we learn to talk about something that is heavier even though it's smaller? We just learned it today and it starts with a D. The small tape is more, Moon?
It's more dense.
That was really close. Say dense.
Dense.
Everyone say the small tape is more dense.
The small tape is more dense.
Very good. So here we have this small thing, right? We have this that's bigger. The small thing is definitely more dense. Even here, oh, let's see, our balance tells us, wow, maybe they're right around the same. Okay, anyone else have a scale or a balance near them and they could maybe compare something or tell us about something? Go ahead, Moon. A scale. Can you weigh something next to you and tell us what it weighs?
Okay. 138 grams.
What did you weigh, Moon?
Yes.
Is that wood? I'll say wood. Okay, I sent a message to everyone. Who else has a scale? All right, Bunny, go ahead and weigh something next to you.
Very good. What happens to Tadpole's tail? What happens to Tadpole's tail?
So it was 255.
And is that a cup of water?
Just up.
Just a cup. Okay, let's do one more. Anyone else have a scale next to them? Zook?
Put the computer on the scale.
Okay, so this is a computer.
It's 4 kilograms.
How much is it? 4 kilograms?
Yes.
Wow. All right. So who can tell me, Sam, what do you think? Which one is the heaviest?
The wood.
The wood is 130 grams. The cup is 250.
The computer.
Good. 4 kilograms. Let's see. Susu. Susu, which one has the most mass? Which one has the most mass? The wood, the cup, or the computer?
The computer.
Computer, very good. And Sam said that the one that weighs the most was also the computer. Who can tell me which one has the most matter? The most matter. Let's hear from Sino. Sino, which one has the most matter?
Miss Miranda, I was wrong already. That was a laptop.
Say again, Zook.
The thing I with that is a laptop.
Okay. Sino, which one has the most matter?
I think a laptop.
Very good. More mass equals more matter. Okay. Very good job, everybody. We're pretty much out of time. Oh, so we just did this. We did some measuring. We did some weighing. Are these cups empty? Who can answer for me? What do you think? Sophia, are these cups empty?
No. Yes. They are empty.
Rosie, what do you think? Are these cups empty?
No, it has air in it.
Very good. There is gas in them. There is matter inside these cups. Okay, our next lesson is going to be about changing matter from liquids to solids.
Yummy.
Some of them we might use heat. For example, if we add heat to a solid, it turns to a liquid. If we add more heat to a liquid, we get gas. Solid to liquid to gas. The other way around is true as well. If we have a gas like the cloud and it gets colder, it will turn into a liquid. And when that liquid rain gets even colder, it turns into a solid. So we'll take another look at this next class. The other thing I want to talk about one more time is solubility. Just like in Moon's fruit jelly, if it mixes in the water like this, it is soluble. If it does not mix with the water, it is insoluble. Everyone unmute and say these two words, soluble and insoluble.
Soluble and insoluble. Soluble and insoluble.
Very good. So your homework is, today we learned some matter sinks, some floats. Solids and liquids do not change volume or mass when moved. And 3, when matter mixes with water, it is soluble. And if it doesn't mix, it is insoluble. So you will drop 3 different things in water. What happens to them? Some examples of things you could drop would be sugar, milk, salt, cotton, oil is a fun one, a toy. Make observations about them. Do they float, mix, sink? Do you think it's soluble or insoluble? So you're dropping 3 things in water and observing if they mix with the water or if they stay separate. Are they soluble or insoluble?